think it's 17. But yeah, some of them are, extended questions. So here we go. First thing we've got to do with any graph in physics is when we look at a graph, we need to check out the x and y axis and double check this is a DT graph. Now, when I'm looking at a DT graph, don't forget a DT graph tells me the speed of the object. The cool thing, even though speed is a scalar, DT graphs or graphs in general still tell me if my object is going in a positive or a negative direction. Is it leaving the origin or is it coming back? Back would be in that negative direction. Okay, but we don't have to indicate positive or negatives on these because they really truly are scalars. Either way, the other thing is, let me toss it out there, on DT graphs, they're pretty much there. I have never seen a DT graph below the x-axis. I mean, could it? I mean, I guess, maybe, I don't know. But I've only seen DT graphs above the x-axis. Now, the other cool thing on DT graphs is wherever you see a flat line, those could be on the x-axis, but they could be above the x-axis. Any flat horizontal line with no slope means that my object is at rest. My object is at rest. Before I do any questions, me personally, I'm going to analyze that graph. Now, when I have a direct relationship line like A or E, that means my object is moving at a constant speed away from the origin. Constant speed away from the origin. And if I have an indirect relationship line, that means that my object is moving still at a constant speed, but it's moving back in the negative direction, to be honest, towards the origin or back towards home. So a constant speed back. So I just wanted to analyze my graph before I did anything because some of us turned in this homework, and believe me, I'm not going to take off because you got it wrong, but some of us got some questions incorrect. So let's go over it. Okay, question number one. Question number one says here, at what position or distance, because the word position and distance mean the same thing. At what position is my object at for T2? So if I go to T2, which is time, and I come over here, and I can move all the way over here, I can see that I'm at 2 meters. Hopefully you agree with that, but that's what I see, 2 meters. Next thing, question number 2. Question number 2 says over here, what is the speed of the object at T2? Okay, well, I know that speed equals d over t. Okay, you don't have to memorize it. It's on your formula chart. But my t is 2. That's what they told me. My distance is 2 meters. And so 2 divided by 2 is 1. So hopefully you wrote 1 meter per second because you did not want to leave a number without SI units. All right, we don't want a number without SI units. I like that answer. Question number 3. We got to pick on somebody. We're going to pick on Robert. Robert, today's your day. Bless you. What is the speed of the object at t 5 seconds, Robert? All right. Can you tell me how, well, I'm going to come over here. Speed equals d over t. And I'm going to do this also. I'm going to say T7 is, whoa, forgive me. T5. Woo, I caught that, thank goodness. T5 is right here. I'm going to come over here. All right, and speed is d over t, and obviously t is 5 seconds because they said T5. What did you get for the distance number for question number 3? Say you get 4? You got 4 meters, because if you come over here and you look this way, Robert got 4 meters. So 4 divided by 5 is point something. But Mr. Shannon over there is already arguing regarding question number 3. He's probably arguing because he wrote something different on his homework and he's listening to you. And then he listens to me. And then he's like, oh. So, Mr. Shannon, again, today's a picking on you because we're about to have a quiz and I need us to pay attention. And it's early in the morning. Who wants to do this kind of math at 9:30 in the morning? You know what I mean? Like, seriously? Don't shake your head and agree with me. So sometimes, yeah, our quizzes might be a little hard because, yeah, you're doing physics at 9:30. But I promise you, pay attention is going to help you. Mr. Shannon, you look like you are arguing with Robert.
I wasn't arguing, but like.
I saw your eyes.
I disagree.
He did like, almost like a side eye.
No. Ryan
Yes,
asked
you
me
did.
a question. No, here, okay, let me.
Okay, go ahead, say it.
Ryan said, why'd you write zero?
Why'd you write zero?
That's what he told me, and I said.
Why you want to put your nose in this business and it's not part of you?
Well, it's up to me, something.
Your eyes.
When he was. I didn't even
Your
know who
eyes.
Robert was, so how was I looking at him if I didn't know who he was?
Okay, seriously. We're going to pause for a moment. What did I do? Number one, what did I do? I labeled it as a DT and a VT graph, correct? Number two, what did I do before I went to any question? I analyzed each line, didn't I not? Boom. Line B, Ryan. What did I write on line B? Rest. What's the speed of an object at rest? I agree with you. Oh, Shelby's changing her answer. I'm sorry, I don't want to put, she's like, oh, I better change that. Oh, yeah, she changed it back. Oh, okay, okay. All right, seriously, I've got to pick on this so that way we can, we can get this, okay? We've got to. But now that Ryan already jumped into the game over here, Ryan, question number 4. What's the speed of the object at T7? Can you, before you give me the answer, could you, I'm going to put speed equals D over T. Could you give me the T is obviously 7, and I'm going to come over here, and I'm going to come over here. What'd you get for your distance? 2.5. I mean, that's what the graph's telling me. 2.5. And anybody else who wrote 2.5 over 7 is wrong also. Ah, man, this month is being harsh today, shall we? Okay, seriously, I like this homework because let's all look at it. It looks like it's very easy, cheesy stuff, but it's definitely at least 6th grade level. Let's be honest, it's at least 6th grade level. No joke, I'm not messing with you now. I like this question number 3 because I agree with Mr. Shannon that it is 0 meters per second. Why? Because we analyzed it and we wrote rest before we did anything. And what did we do on question number 3 where we got 0? We analyzed the whole entire line. We were finding the whole rise over run slope of line B for question 3. Now that's what we did for question 3. We need to do the same thing for question 4. So real quick, I'm not trying to be mean to pick, but I want us to really pay attention. Mr. Ryan, could you tell me what this number would be? 2.5 divided by 7. What would that be? Seriously. 1.8? 2.8. 2.8. I'm just going to write that there. Okay, now let's pause for a moment, and now let's go and analyze the whole slope of that whole line. What line is that, Shelby, that we're talking about right now? I have no idea. Oh, I love her answer. Line C. We're analyzing line C. So if I want to find the slope of all of line C, then let's come over here, because over here on question 3, didn't I analyze the whole line for line B, and that's how I got 0 at rest, because there was no motion? Let's analyze this whole line for line C. what would be my distance now over here? My distance covered is 4 to 1. That would be a difference of 3. The time that occurred is 6 to 8. That would be a, and that would be a 3/2, which comes out to 1.5 meters per second. That is the correct answer. All right.
How we got 3 divided by 2.
Absolutely. Now, before I can go in and explain how we got 3/2, I've got to go back to remind us that I like how these questions are in this particular order, because on question 3, we had to analyze the whole line B, which is a flat horizontal line. Even though in our gut, we want to do 4 divided by 5, because on question number 3, they were talking about T5. And so in our heart, we want to go to T5, go up, and scroll over here to the y-axis and say, oh, the distance is 4. 4 divided by 5 is point something. Nope, not today, Satan, because we're smarter than that. We're analyzing the whole line B, which is a flat horizontal line, and that means at rest, and that's where we got 0. Now, when we were analyzing the whole flat line for B, when we moved on to question number 4, then at T7, which is part of line C, then we're going to analyze the whole line C, not just T7. We're analyzing the whole slope of that line, which is everything that had occurred. So everything that occurred on line C was D, okay? The distance for line C covers this section to this section, which is 3 meters. That's where I got 3 from. And line C covers this much T, 6 to 8. And that's where I got 2 from. 3/2 is 1.5. The actual slope of that line, or speed of line C, is 1.5 meters per second. Okay? Other than that, those 2, I think, were the tricky questions. That was it. Everything else, I bet you got right. Okay? So let's go ahead and let's keep going, because I just wanted to analyze this a little deeper for some of us. Yes, sir?
I'm a little confused on displacement. Right?
Mm-hmm.
Just number 10.
Which question?
Number 10.
Okay, we can skip to number 10. Displacement is, where did you end up at the end compared to the beginning? So if displacement, question number 10 says, what is the displacement at 14 seconds? Well, what is the difference or the comparison from the end to the beginning? What's the, look over here, the difference between the distance between here and here. Looking at this. What's the difference? Nope, you look up here. What's the difference between here and here? Look at my fingers. Look at this line. Look at this line, that green line. 0. 0. It started here and it ended here. So 0, I agree, 0 meters. But wait a minute. Remember, displacement and total distance do not have to be the same answer. This question says, what is the total distance at 14 seconds? That means that I need to go and add the distance for every single line. I need to analyze that section. So from here to here, it traveled 4 meters. From here to here, it traveled 0 meters. From here to here, it traveled 3 meters. From here to here, it traveled 0 meters. From here to here, it traveled 7 meters, and from here to here, it traveled 8 meters. Check my math, but when I added 4 plus 0 plus 3 plus 0 plus 8 plus 7, I got a total of 22 meters.
Yeah.
Okay, that's what
I
you
have a
got.
quick question.
Yes, sir.
Not meaning to go back there.
No, 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 absolutely.
But on question 1, it asks kind of a similar question to question 4, and it says t equals 2 seconds. Why didn't we solve for the whole line on question number 1?
So solve for the whole line now. No, 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 I want you to.
Oh.
No, I'm asking you, Mr. Shannon, to solve for the
Oh.
whole line. No, yeah. So what would be my total distance? Would be 4 over 4, which equals 1.
Okay.
It so happens to be the same number. It just so happened to be 1. That slope is 1.
Okay.
That steepness of the slope is 1.
Okay.
Yeah. And so when we get over here, I just like to break it down and put, but you're right. You're right. We should have analyzed the whole slope of line A. Yes, always. On a DT graph, analyze the slope of everything. I would personally.
Wait, I'm so confused how we got 2.
Where do we got 2 here on number 1?
I was talking about question 2. That's not bad. I missed that question.
No, I'm talking about how we got 2 on question.
Oh, we got 2 here?
4.
Question
We got
4?
one question.
No, because we got 3 over 2. I get where we got the 3 from, but where did we get the 2 from?
Oh, the difference in time,
Mm-hmm.
or the amount
Right
of
here.
time.
This was 2 seconds, 3 over 2. 6 to 7 is 1 second, 7 to 8 is 2 seconds.
It's total distance of the total time of the line.
Okay, so the 3 is from the time?
3 is from the distance, from 1 to 4.
Cause look. Right from right here to right here, it's a total of 3 meters. And it's always distance of the top, right? And the total time of this line is 2 seconds. So it's 3 over 2.
What do you mean? This is the time that this line occurred. And these is where it ends, where it starts.
Hey, I think it's awesome, because like I said, I don't think I always explain stuff the way, somebody understands. There you go, it's good. Here we go, double check your answers, double check my answers, but I'm pretty sure these were probably easy. During which time interval is the speed of the object the greatest? That means the steepest slope, right? Which is letter E, which was the steepest slope. And you can definitely, either number 1, you can do the math, or number 2, you can look to see which one is the steepest line. Next one, number 6, the correct answer here, which one is at rest? Well, we've already analyzed that. That's going to be letter B and letter D. During which time interval is the object moving forward? Remember how I analyzed forward is away, back is moving back towards the home. So we analyze that, C and F. And then the last one over here is F. So please, my suggestion would be to analyze a graph before you do any of the questions. Just like regurgitate everything you know off that graph. Now I'm going to move this because there's a question, and I think it's the last question on the quiz that's going to be kind of like one of these. And I want to go over them with you. First step is we need to analyze what type of graph is it. And I guarantee you, you're about to see one in just a moment. This is DT, this is VT. The other thing that I like is, what did I say a minute ago? All DT graphs are really, truly above the x-axis. When you look at this one, there's no tick marks, there's no nothing, no numbers, but what they are trying to tell you is that this right here is the x-axis, or 0. So everything up, if you want to, you can just put little numbers. You can make up your own 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 seconds, whatever. But look at this. Did you realize that this is the actual 0 x-axis on the VT line? And so I just wanted to make sure, because you are going to have a question on the quiz. So that is actually the x-axis. We go over this stuff just so we can practice together. Now, what did I mention? Please analyze the lines. So when we are over here, we can see we're at rest, and a flat slope or a nice pretty slope like line B and D means my object on a DT graph is constant speed, but this one right here is moving back towards the origin, and this one is constant speed away from the origin. Now, the one thing that you do need to pay attention to is you can either call these like little columns, rows, numbers, but line A goes to 3, line B is for a section of 2, line C goes 3, 2, 3, and line D goes a section of 2.
Wait,
Uh-huh.
it goes 3, what do you mean?
Like, it goes like 3 seconds wide. It goes like 3 seconds wide, like 1, 2, 3 wide. Yes, good call, good question. And that goes like 2 seconds wide, 3 more, and 2 more. But now, in a moment, you are going to have to draw a similar one that matches the other one. So let's practice. Okay, if it's at rest, those are easy because on a VT at rest, they're just flat lines on the x-axis. So I'm going to come over here with a, here we go, orange Sharpie. But look at this one. It goes 3 wide or 3 seconds. So it's at rest, 1, 2, 3 on the x-axis. Okay, I'm going to skip 2 seconds because that's this slope right here. Then I'm going to go skip 1, 2. The next one is 1, 2, 3. I'm just going to knock out those 2 easy ones, right? Now I've got a constant speed back, and then I have a constant speed away. Remember what I kept on saying? Back, above, away, away, above, back, below. Forgive me. One more time. A, away, above, away. A, away, above, back, below. So since this one is back, I don't care on the test, quiz, semester exam. I know that it needs to be below the x-axis. How far below? I don't care. I just want to see something below. This one is away above, right? Where? I don't care. And your line looks like this. X below, X above. But wait a minute, Miss Munson, that's literally what it looks like. If your gut feels like it needs to connect, then you can do this. You can do that. And that's what they did on the next graph. You see how they did that? That's how they connected that.
Wait, so
Mm-hmm.
I got this one.
this is asking
Because also
like,
brightest one,
never mind. I got it.
You should, okay. So this is just asking you to look at the DT graph and create a VT graph that matches it. Remember when you were doing those walking thing? It may not make sense then, but now you probably like, oh, that's why there was 2 graphs, because you were able to compare the DT and the VT at the same time. Sometimes your labs may not make sense at first, then maybe later on they will. Let's look at this again. Step 1, analyze DT, VT, and x-axis, x-axis. Okay, now let's check out what each section. There are 3 sections on this VT, so I need to draw 3 sections on the DT graph. Okay, well, let's start off with the easiest one. The easiest one would be rest. And where do you put rest over there? I don't care. Just as long as it's a flat horizontal line. Okay, wait a minute. Line A is above, line B is below. Away, above, back, below. So this is constant speed away. This is constant speed back towards the origin. Okay, now I am going to analyze this part. I'm going to look to see, this is 3 seconds for this line, 3 seconds, 3 seconds, and then the last part of it. Alrighty, so let's do that. What am I going to look like for a constant speed away? Oh, wait a minute, right here. It's going to be an upward direct relationship line. Constant speed away. For how many sections or how many seconds? 3 seconds. Where? I don't care. 1, 2, 3. 3 seconds. Oh, that's kind of hard to see. 1, 2, 3. Then go back for 3. 1, 2, 3. I'm listening.
Why are we starting above that?
I don't care.
Oh.
I just, yeah. Some of us started right on the x-axis. I just want to make sure that I see it's a direct relationship, an inverse line. And then after that, the rest is where did you put rest? I don't care if it was on the x or if it was above. Here's what we did last period. Look at their slope. Up, down, and then their flat horizontal line was above. I don't care if it's above or where, as long as it's a flat line. I wanted to see a direct relationship, an inverse line, and then a flat line. Then the last part, let's do this again. This is constant speed for dt, and this is vt. Oh, wait a minute. Look, this is the x-axis right here. This is the x-axis over here. So in this situation, I'm going to come over here, and I agree 100%. Constant speed, away. This is easy. Rest. And then we have a curve. Okay, this one actually is not speeding up. This curve is actually slowing down, but it's up. Well, no, they're all above, but this one is away though. It so happened to be away. Can I pause for a moment and go to our notes? And do you see this curve? Here's our notes right here. That's the same curve as this, means that it's slowing down away. So it is away, but this curve is this curve right here.
Yeah, I'm not gonna lie, the speeding up and slowing down is like mixing them up.
Can I tell you that this one is not the one that's on the quiz? Okay.
That's probably the second one.
Oh, I don't know, but I know it's not this one. It doesn't have a curve. I'll tell you that. So let's go ahead and let's draw this out. For this one over here, a constant speed away is above the x-axis, but I don't care where you put it above. Just stick it above. And it goes for 1, 2, 3, 4, about 4.5-ish. Slowing down. Whoa. On a DT graph, I promise you this one's not on the quiz, but on a DT graph, when we have curves, that means my object is accelerating, okay? It's accelerating if it's on a DT graph. So when it's on a VT graph, it's going to be a direct relationship or an inverse slope line. It's not going to be a flat horizontal line. So in this situation, it should now go like this, and then my flat line on the x-axis. Yes, I will zoom out, so that way you can look at them all. There you go.